The graph of the parabola in vertex form is f of x equals a times x minus h squared plus k. In this diagram, a is greater than 0, so it's upward facing. H is less than 0, so it's over here on the left side of the y-axis. And k is also less than 0, meaning that the vertex is going to be down below the x-axis. X equals h, and that's our axis of symmetry. And we have our vertex at h comma k. In this diagram, we have a downward facing parabola, therefore a is less than 0. H is greater than 0, so the axis of symmetry is to the right of the y-axis, and k is greater than 0, meaning that the y coordinate of the vertex is going to be above the x-axis. Exercise A. Consider the graph of the parabola f of x equals 2 times x minus 3 squared plus 5. Determine the y-intercept and its mirror point. Alright, to find the y-intercept, we just have to plug in 0 for x and see what the output is. So that would be 0 minus 3 squared plus 5. So 3 squared is 9, times 2 is 18, plus 5 is 23. So that would be our y-intercept. And we'll confirm that here. So the mirror point is going to be 6, because you take your axis of symmetry and you double it. To visualize that, let's visualize this parabola. So because h is 3, it's going to be here, and this point is h comma k, and here's our h, and here's our k. So k is 5, and h is 3, because remember in the standard form we have x minus h. So if it's minus 3, that means h is positive 3. So this looks something like this. It intersects the y-axis all the way up here at 23. Now our axis of symmetry is at 3, so if we want to mirror this point over here, we take our axis of symmetry, 3, and double it, because this will be over at 6, 23. So that's how we solve for the mirror point. Exercise B. Consider the graph of the parabola g of x equals negative 5 times x minus 1 squared plus 2. Determine the y-intercept and its mirror point. Alright, the y-intercept will be when x is 0. So we have negative 5, 0 minus 1 squared plus 2. So we have 1 squared times negative 5, which is negative 5, plus 2, which is negative 3. So our y-intercept is at 0, negative 3. Now to find the mirror point, that will be, the y value will be the same. So we have negative 3, but we're going to take our axis of symmetry and double it. In that case, our h, which is our axis of symmetry, is positive 1, because that is where this will become 0, and therefore this point, the mirror point, will be 2. So we can visualize that here. Alright, so this is what our parabola looks like. It's downward facing because a is negative. We have our y-intercept at 0, negative 3, and its mirror point is 2, negative 3, because if our y-intercept's here, our axis of symmetry is at 1, therefore the mirror point would be at 2. Consider the graph of the parabola in vertex form. f of x equals a times x minus h squared plus k, where a is greater than 0, so it's an upward facing parabola. Determine the y-intercept and its mirror point in terms of a, h, and k. Alright, so we have our hk, that's our vertex here. Therefore, our y-intercept is just when you plug 0 into the function, and we get f of 0 out, and then the mirror point will be 2 times h, remember, because h is this distance between this line and this dot, so 2 times that distance with the same y coordinate as the y-intercept. Here are the steps to graph a quadratic in the vertex form. So if we have f of x equals a times x minus h squared plus k, step 1, find the axis of symmetry, which is h. So this number here. Step 2, find the vertex, which is at h, k. So k is this number here. You can also just plug h into the function and get your y coordinate. Step 3, find the y-intercept. Plug 0 into the function and get your y-intercept. Step 4, find the mirror point. You have the same y coordinate as the y-intercept, but your x coordinate will be 2h, which is 2 times your axis of symmetry. Step 5, connect the dots. All right, let's graph this together. Here we have h equal to -2. It's -2 because it's always going to be the opposite of whatever sign you see in front of it. It's because the standard is x minus h, so whenever you see +2, that means that h equals -2, and that created x minus -2, like that. So, and those two negative signs canceled out into a plus sign. So h here is -2 and k equals 1. So step 1, find the axis of symmetry. That's h of -2. So we draw a red dotted line at x equals -2. Find the vertex. All right, that's going to be -2, 1, because this number over here is k and that is 1. So we draw a dot right at -2, 1. Find the y-intercept. When we plug 0 in here, we get 2 squared plus 1, which is 4 plus 1, which is 5. So 0, 5. It's also a times h squared plus k, but that's just what you would get if you made x 0 and included a. A here is just 1, so we don't need to include it. All right, step 4, find the mirror point. So we just mirror this onto the other side here, and we can also mark that down as having 5 as the y-coordinate, and then 2h. h is -2, so 2h is -4. And then connect the dots. Sketch the graph step by step. All right, so here we have an h of 3, because remember, it says -3, so h is going to be +3. We have a k value of 2, and we have an a value of -1. So this is actually going to be a downward facing parabola. First step, find the axis of symmetry. H equals 3. So I will draw a line at x equals 3. That's our axis of symmetry. Next, find the vertex. The vertex is h, k, which is 3, 2. So 3, 2, right there. That's going to be the vertex of our parabola, this point there. Find the y-intercept. All right, so let's just plug 0 in. So h of 0 equals -0 minus 3 squared plus 2. So -3 squared is 9, but there's a negative sign here, so -9 plus 2 equals -7. So y-intercept is down here. Next, we're going to mirror that over. So if this coordinate here is 0, -7, we know that the y-coordinate will be the same, -7, and we just need 2h, so 6 as our x-coordinate. So 6, -7. You can also visually see that this is 3 units away from the axis of symmetry, so you just count 3 more units away. And then finally, connect the dots. I'm pretty bad at freehanding these, but let's see. There we go. And it goes down to -infinity. And it looks good to me.